Okay, so here's me going through your time trial paper 2. So question 1a, they ask you to draw the Lewis diagram for hydrazine. Okay, so you know that hydrazine, this is the formula. So how I always draw Lewis diagram is, first, identify what are the elements and then write down what's the number of valence electron, how many more does it need, okay? And you should know that this is a covalent bonding, so you should draw them sharing electrons, okay? Nitrogen has 5 valence electrons, so it needs 3 more. Okay, hydrogen has 1 valence E, needs 1. So how can I arrange it such that there's 2 nitrogen and 4 hydrogen at the same time? Okay, now usually the one that appears the lesser number of times, like among nitrogen there's only 2 nitrogen, hydrogen there's 4, right? So usually those that has lesser atoms are in the center. Okay, so let me draw the nitrogen in the center first. Now there's 2 of them, so how can they join? It can be a single bond, it can be a double bond, or a triple bond. Now, but if it's a triple bond, then it's just a nitrogen gas, cannot bond to the other 4 hydrogens, right? So GT is a bit like trial and error lah. Okay, what I do is, okay, so this will be the structural formula. In this way, each nitrogen will get to form 3 bonds, each hydrogen will get to form 1 bond, so everyone will be happy. Everyone will have the correct number of valence electron. So let me just draw in the electrons. So let me just write a key. The cross is the electron of 1 nitrogen. Dot is the electron of the other nitrogen. And the triangle is the electron of hydrogen. Okay, let's continue. So second question asks you to calculate the heat of reaction delta H for the reaction between hydrazine and fluorine. Now for this kind of question, I will draw out the structural formula first, so it's clear to me what exactly are the bonds that I need to form, what exactly are the bonds that I need to break. Remember that for your reactants you need to break the bonds, and for your products you need to form the bonds. Okay, so and also remember that this is energy required, and this is the energy that's given off. Okay, so how do I write my delta H? Delta H equals to the energy required to break them. So let me just use a big square bracket. How many NH bonds do I have? Let's count. 1, 2, 3, 4. 4 NH bond plus 1 NN bond, 163, plus 2 HF, FF, 1, 5. So these are the energy required, so it's positive. Okay, then you will minus off the energy that's given off when it's formed. Okay, so what's the energy that's given off when it's formed? 1 N triple bond, 9, 4, 5, plus 4 HF, 6, 5, 6, 5. Okay, that should give you the answer. Let me find the answer key. Okay, negative 1166 kilojoule per mole. Okay, draw a fully labeled energy diagram for the reaction between hydrazine and fluorine, indicating clearly the delta H in your diagram. Now note that your delta H is a negative value. So which should be higher? Is it reactant higher than product, or product, or is it product, or is it the other way around? Or is it this way? Now remember, for the delta H to be negative, it should go down. So your reactants should be here, your products should be here. It's an energy level diagram, so you do not need to draw the hump. Okay, so let's just write down what are the reactants. N2H2 H4 gas plus 2F2. This will give us N2 plus 4HF. Okay, always remember to label the delta H with the sign. Question C. Okay, so type 2 rocket, it burns with oxygen. So what do we have? We have water vapor and nitrogen as the only products. And it gives us the energy change of this. State one advantage and disadvantage of using this as compared as using hydrazine with fluorine. Okay, so in the question, they already give you the hint. First, they tell you what are the products. Second, they tell you the delta H. So it means that it must be that they want you to compare these two. Compare their products as well as compare the energy change. So, as you recall, the product of this reaction is nitrogen, this is the same, as well as hydrogen fluoride. Now, hydrogen fluoride is more dangerous as compared to water vapor. Okay, if you compare HF versus water, this is more dangerous. Why? Okay, because this is acidic. Okay, it's an acidic gas. So, as compared to water, which is neutral, the production of HF is more dangerous. So, the advantage of this fuel is that it is safer. The disadvantage though, you can compare the energy change. One is negative 587, the other is 1166 kJ per mole. So it's almost twice of that. So the energy release is lesser when we use oxygen gas reacting with 1 mole of hydrazine as compared to using fluorine gas, F2. Okay, next, A2, a common kind of question where there's two types of cell. Okay, one side we have platinum electrode, the other side they did not tell us what kind of electrode it is. Oh, they did, it's just that my diagram is wrong. Okay, copper. Okay, so how do you do this kind of question? First, you see that there's a battery, right? Always follow the battery first. Okay, the longer line is positive, so it tells us that this is the positive electrode. Shorter line is negative, tells us that this is negative. Then the electrode that is together with it cannot be of the same sign. So this must be negative, this must be positive. Name the product at the following electrodes in cell 2. Okay, so let's think. In cell 2, it is in your dilute sulfuric acid. So what are the ions that can move to the positive electrode? Okay, it must be negative ions. So we have your sulfate ions and we also have hydroxide ions. What can move to the negative ions, negative terminal? It will be your positive ions. In this case, there's only H+. So what are the products in the cell? Remember that sulfate will never be preferentially oxidized, so it will be hydroxide and hydrogen being reacting. Okay, so at the positive electrode, we have oxygen gas and water. Okay, but you just need to write oxygen gas because we can't see the production of water. Okay, and the negative electrode, we have hydrogen gas. Now, this is the part where I think students may not understand what's going on. If the mass of the negative electrode in cell 1 increased by 3.2 gram, calculate the volume of gas at room temperature and pressure collected at the positive electrode in cell 2. So let's look at cell 1, the negative electrode. Here, if it increased the mass by 3.2 gram, what is the volume of gas collected at the positive electrode? Here. Okay, so first we must figure out what's the identity, what is causing this increase in mass. At the negative electrode, for a silver nitrate solution, it can either be H plus or Cu2 plus. Of the two, Cu2 plus is lower in the electrochemical series, so you should know that The increase in mass is because copper 2 plus is being reduced to become copper metal. So given that, you can find the number of moles of copper by taking 3.2 dividing by 63.5, 0.050393 mole. Okay, let's write the half equation. Cu2 plus 2e minus is as Cu. Okay, so this is the increase in mass because of this. Now, given that this is the number of moles of copper formed, I can also calculate the number of moles of electrons that's transferred from one end to the other. So number of moles of electrons will be times 2. What's wrong with my times 2? Okay, which equals to one value. Okay, and then at the other side, you know that hydroxides are reacting. So 4OH minus gives us O2 plus 2H2O plus 4E minus. Okay. Actually, we don't need to calculate the number of moles of electrons here. You can just combine the two half equations together and you get the overall equation. Okay, so the overall equation will be 4OH minus plus 2Cu2 plus gives us 2Cu plus O2 plus 2H2O. Okay, so you know that copper and oxygen gas is 2:1. So number of moles of oxygen gas, you take 0.050393 divided by 2, you'll get 0.025197 mole. Okay, since volume of oxygen gas, just take this number times 24 dm cubed, it will give us 0.605 dm cubed to 3SF. Okay, B. If I change the electrolyte in cell 2 from sulfuric acid to ethanoic acid. Okay, the first question is a definition question, so I won't go through. Part 2, if the mass of the negative electrode still increased by 3.2 gram, would you expect the volume of gas collected at the positive electrode to increase, decrease, or remain unchanged? Explain your answer. Now, if I change this acid to ethanoic acid, so what are the changes? Let me use another color to indicate that it has changed. Then there will be no sulfate ions, but instead it will be CH3COO minus. Okay, and the other side is still hydrogen gas. Now between these two, what do you think will be preferentially oxidized? Okay, I've never taught you this before, right? So it will be unreasonable for you to know lah. Okay, they tell you that there's a gas evolved, so it means that it must still be your hydroxide. Now, why is it that there's how can we do this? So if the mass of the negative electrode in cell 1 increased by this amount, it still tells us that the number of moles of Cu is the same. Okay, the number of moles of electron transfer is the same, and hence the number of moles of oxygen gas produced is still the same because there is no change in the product. Okay, so there's a few things you need to mention. You need to mention that the number of moles of electrons transferred is the same. You need to mention that of the two anions, hydroxide is preferentially reduced. Okay, 1, Cu same, 2, what did I say? OH minus versus CH3COO minus. OH minus pref C2 O2 still. So therefore, same mole of oxygen gas produced, same volume of oxygen gas. Okay. Question 3. 2.5 gram of alloy of copper, write an overall equation for the reaction. Okay, so first, to write an overall equation, look here, this 5, this 1. So I must first multiply this equation by 5 to make the number of electrons balance. Okay, we did this before in class, so let's try writing this down. MnO4 minus plus 8H plus 5 Fe2 plus gives us Mn2 plus 4 H2O plus 5 Fe3 plus equals. Okay, an average titration required 12.5 cm3 of MnO4. Calculate the number of moles of Fe2 plus present in 25 cm3 of the solution. So actually this is a back titration reaction. Let's read carefully. Okay, just now I skip over. So 2.5 gram of an alloy of copper and iron dissolved in sulfuric acid to produce a pinkish brown deposit in a pale green solution. Now, what is this pinkish brown deposit? This is your copper that's unreacted, because copper doesn't react with the acid. Pale green solution, this is actually your iron 2 plus. Okay, remember iron 2 plus solution is pale green. Then you filter it off, dilute it to 250 cm3. Then you take out 25 cm3 from this 250 cm3 and titrate it with this number of moles of this concentration of KMnO4. Okay, so since it's that concentration, let's find the number of moles of MnO4 first. 12.5 divided by 1000 times 0.001 molar. Okay, what's this answer? Let me see. Wow, a lot of 0.0000125 mole. Okay, now it is 1:5, so number of moles of Fe2 plus equals to 0.0000125 times 5, which equals to 0.0000625. Okay, this one mark, this one mark. Calculate the percentage of iron in the alloy. Now, after I calculate the number of moles in 25 cm3, I can find the number of moles in Fe2 plus in 250 cm3, which equals to is times 10, so 0.00625 mole. Okay, so if that's the number of moles of Fe2 plus, I can find the mass of Fe in the alloy. It will be 0.00625 multiplied by the mass, which is 56, 0.035 gram. Hence, the percentage of iron is, the initial mass is 2.5, so 0.035 divided by 2.5 is actually only 1.4%. Okay. Next part, question 4. To reduce the amount of air pollutants, the exhaust system are fitted with catalytic converters. The figure below shows the structure of a catalytic converter. Nitrogen dioxide, carbon monoxide react together to give Okay, how are they formed in the car? Very simple. For carbon monoxide, it is produced whenever there's incomplete combustion of fossil fuels. For nitrogen dioxide, the high temperature in the car engine causes the nitrogen gas and oxygen gas in the air to combine to form nitrogen dioxide. So what happened over here? Nitrogen dioxide and carbon monoxide became nitrogen gas and carbon dioxide. So you just need to balance the equation. Part C, explain in terms of oxidation state number why the reaction between nitrogen dioxide and carbon monoxide was a redox reaction. So first, tell me what is reduced, and the other is tell me what is oxidized. Okay, state what is reduced as the oxidation state number of the element decrease from the number in the species to the number in the species. Okay, same here is reduce oxidize. Oxidize when you increase oxidation state number from +2 to +4 in the species. Okay. Then the rest, let me use a separate video. Okay, that's all. Thank you.